Hey guys, we're going to continue on with our similar triangles that we're working on. We looked at three rules that allowed us, or sorry, three conditions that allowed us to know whether two triangles were similar or not. So I'm just going to quickly review those and then give you some examples of how we work with that. So the first rule here would be the A rule, angle rule, or the side rule, or the SAS rule. And if you look at the video before this one, we went through how to determine those things. So if I was to look at a triangle, once again, I'm going to, just for time purposes, just draw this freehand. So I really should be using a ruler to draw these triangles. But let's say this, this triangle here, we'll call this triangle ACT. And another triangle over here. We'll call this one, I don't know, Ben, triangle BEN, okay? Now, let's say you were told this side was 8, and this side was, let's say, 12. And the side over here you knew was 4, and this was 6. And we told you that this angle was the same as this angle, okay? And then we ask you, are these triangles similar? So are they similar? Like many questions that are yes and no questions, you could just say yes or no. But you kind of want to say why. So we're really looking at why are they similar, or why are they not similar? So we want to answer that question first. And then if they are similar, then we'd want to write a statement that would relate the triangles to each other. So I could say triangle ACT is similar to triangle something, but only if it is similar, of course, right? So you can't say they're similar just because you want to say they're similar. So anyway, so do these two triangles meet either of these three criteria here? Well, it looks like I've been given two angles and a side. So I guess I would want to know, is this true then? So I guess, is this sassy triangle actually similar? And so the rule for SAS triangles is you have to have one angle that's the same, which we have, and then you have to have two other sides, but then those two sides have to be proportionally related to each other. So it looks like the line AT, this 8 here, is double the line BN. So it's twice that value. So that's a relationship. But what would have to be true now is the other side would also have to be double or half, depending which way you're going. So to go from 8 to 4, we would have to divide by 2. And to go the other way, you'd have to multiply by 2. And of course, to go from 12 to 6, we would have to divide by 2. So proportionally, we're doing the same thing here. And so this would be classified as a SAS triangle, and they would be similar to each other. So, okay, so what does that tell us? Well, we have to be careful when we say they're similar. So which things are congruent to each other? So congruent, actually, I shouldn't use the word congruent, actually. Which ones are corresponding? Sorry, different C word. Congruent means equal to. They don't have to be equal to. So corresponding means which sides and angles are related to each other. So corner A is the corner that has the red little angle in it. So this is the one with the red angle. So I have to go to the other triangle and find the letter that has to do with the red angle, which is corner N. So I could say corner N. And then I go to side C. And now, if you look at that, side AC, so side AC is equal to 12. So going from A to C, that's 12. And so the corresponding side to AC would be side NE. okay? Because that's the one that you halved 12 to get 6. So really, I'd have to go from A to C, and I'd have to go from N to E. So this would have to be E. And you don't have to use all these fancy colors, I'm choosing different colors for this. And then if you look at the line C to T. So I'm going to go from C to T, because that's what it says here, go from C to T. Then I would have to go from E to B, neb. Okay, so I'm going to write one more down here. We did this on the other slide here, but let's say you had triangle cat. That would also be similar to the other triangle, but the letters would have to be different now. So which corner corresponds to C? Well, C is the same as, well, sorry, it's corresponding to E. And then A is the red angle, so we'd have to use N because that's the red angle. But notice the T hasn't changed position, so it must also be B on the end. Okay, so that's how we would write similar triangles. Okay, so let's try one. We're over here. Yeah, one like this here. So we'll do one that's kind of, okay. And let's say you're told this side is 12. This side is 10. Okay. And then let's say this side is 30. This side is 38. Okay. And you're asked, are these triangles similar? So are they similar? And then of course, why? I'm going to go back to the question because I never really answered the why part of it. So I guess first of all, are they similar? Yes, they are similar. And the reason why are they similar? Because they follow the SAS rule. So they're a sassy set of triangles. So they are following the SAS rule. So this question says, are they similar? So first of all, we have to figure out which rule we're going to use here. So I can't use the AA rule because I don't know any angles. Or do I? But I do have a couple sides here. But do I have 3 sides or just 2? Well, I just have 2 sides. So I think I'm going to have to try to look for the SAS rule here, because that's the only one that has just 2 sides to it. So is there an angle I actually know here? Well, we do have this X rule, that if you have 2 lines crossing, the vertically opposite angles must be the same angle. So the angle here, that angle there, must be the same as that angle. So I do have SAS, but the other rule to the SAS is that the corresponding sides have to be related to each other by proportionality. So for example, to go from 10 to maybe 30, looks like I might have times it by 3. But then the other side I would have had to times by 3. And 3 times 12 is 36. So these sides do not show any kind of common proportionality. So no, they are not similar triangles here. Okay. So there's a few questions on the sheet I'll get you to work on, and then I want to talk about how you actually use this to solve something. Like, what's the sort of the point of this? So let's take a look at the triangle we just did there, and let's do one where it is actually similar. And let's see if I draw this properly. Yeah, let's do that. So let's say you were told this is 12, and we'll make this side 14. Okay, and let's say this side here, what up on top was 8. Okay, and you were told that down here this was I think here 28. and this side over here was 24. Okay, and I'm going to put some letters in the diagram here. So we're going to say R, A, T, I, M. So I got triangle rat and triangle Tim, I guess. But are they corresponding to each other? Well, first of all, are these two triangles similar? So once again, I kind of said they were. But let's say the question was really at the end of it all is, what is x? What is that distance of mi? Well, we know that proportionality and similarity have to do with those three rules. So the AA, the SSS, and the SAS. So we know the angle here and here, the vertically opposite angles are the same. And if I go from 12 to 24, I've times that by 2. And to go from 14 to 28, I times that by 2. So that seems that they would be similar. So I would say triangle rat is similar to triangle Tim, but I might not be able to say Tim. I don't know if I can actually say those because R, this angle here, would have to actually be related to one of the bottom angles in that triangle Tim, actually. So notice that the 14 and the 28 go together. So that's this side. So that must be this side. And then the side RA there, that would have to be similar to IM. So this angle here must be the angle that's the same. And then the other angles would also be similar. So what we'd have to say is that triangle rat, so RAT, well, R and I are actually corresponding to each other. So I, and then when you go from R to A, so R to A, that'd be the same as I to M. And then you notice angle T in the middle would have to be angle T over here also. It's the shared angle, or sorry, shared corner, I guess you could think of it that way. So these two triangles would be corresponding to each other. Okay, so here's sort of the tricky part now, is that if that's true, then this will be true about all the ratios, is that if you take RA and you divide it, I'll do it the other way, actually. Let's take the bigger ones. Let's take T, or let's do IM. Let's do IM. IM divide by, so remember IM divided by RA. That would have to give me the same ratio as MT, that's the bigger triangle, MT divide by AT. Now that might seem kind of confusing with the letters, but let's see if we can put numbers in. It might make a bit of sense. So what's IM? Well, that's your X value. And what's RA? Well, the length from R to A, that's 8. That would equal MT. So where's MT? M to T, so that'd be 24 over the corresponding side AT, should be here. So that would be 12. So we know this would be, just draw an arrow up here. I know this would be X over 8 is equal to 24 divided by 12, which is 2. And now to solve for this, we would times both sides by 8. 8s would cancel, and we would get x is equal to 2 times 8, which is 16. Now you might have saw that because you want to just say, oh, I just double everything. But imagine if it wasn't double, like maybe it was like 2.5 or, like maybe 3 over 4 or something like that. So it wasn't a nice easy number for you to calculate. You'll find this sort of method of setup quite useful here. And so we look at the corresponding sides here. So this is sort of the ratio of sides. So let's try another question that kind of deals with that kind of concept here. And once again, you might actually have to rewind this video and start again and see what you think about what the values are here. Okay, so let's leave. Yeah, that worked. Okay. Okay, so let's start off with these two triangles then. So let's say you have that triangle, and we'll call that A, B, and C. Let's say you're told that the angle here is 35 degrees, okay? And this side here is 28, okay? And down here you have another triangle that's a bit bigger maybe. And this is 35 degrees. And this side up here is 42, okay? And down here, this side's 33, okay? And what you're being asked to solve for, let's call this angle a DEF. And you're being asked to solve for side BC. So that distance there, what is the length of BC then, or X if you want to think of it that way. Okay, so first of all, we'd have to know, well, if these two triangles are similar, then we'll definitely be able to solve for that. But if they're not similar, then we won't be able to solve it, and X will just be an unknown quantity. So are they similar? Well, it looks like it's very similar to the last question and similar to the question before that, where we might be looking at the SAS rule here. So let's say that you're looking for the SAS rule, okay? Well, we know that 35 is common to both. And then we have this 28, 42, and then we have an unknown and a known. So right now, we actually don't have enough information to determine whether the SAS rule is true or not. Okay, so basically we wouldn't be able to solve this unless we were told something. So let's say on the question we told you they were similar. So let's just say question number 1. And we said if triangle ABC is similar to triangle DEF, find BC, or find X, I guess. Okay. So let's say you were told they're similar now. Well, if they're similar, then what that means is the corresponding letters have to kind of match up here. So that means A and D are corresponding, B and E are corresponding, and C and F are corresponding to each other. So that means they're related to each other. So if I'm trying to find side BC, I want to know BC. Well, then what does that correspond to in the other diagram? Well, BC is from the 35 to the corner angle B. So 33 must be from F to E. So that ratio must equal the ratio of the sides we do know in the other diagram. So notice that I picked A, B, C to go on top, and then D, E, F to go on the bottom. So you have to do the same in the other fraction now. So now we know the length of AC, the 28, has to be related to the side length of DF. Now, if that sort of weird way of writing is a bit hard for you, I think the next fraction is sort of the key fraction we have to deal with here. And what I would do is I would put the x here. I would say, well, that's what I want to find right now. So which side corresponds to BC? So, or the x value? Well, that's the 33, which you'll notice is actually FE. And now what I want to do is I want to make sure that I picked the right ratio here. So I have the triangle, let's call this triangle number 1, and this triangle number 2. So notice that I have x, which is triangle 1, and number 33 is from triangle number 2. And so now I have to kind of keep the same order. So 28 corresponds to 42. So that ratio would be what I want to use here. So x here would have to equal 33 times 28 all over 42. And you know, once again, you're going to want to use a calculator for these kinds of questions. And I don't have my calculator handy. Do I? Oh, I do. I took it to school yesterday. There we go. 33 times 28 divided by 42, which is 22. Okay, so let me just double check that again. So 33 times 28 divided by 42, 22. Okay, so if they are similar, then you can actually solve a lot of properties about the pictures. Okay, so I'm going to go back to a diagram that I did yesterday, or in the other video. It's actually the same day. It may seem like 2 different days, and that's this picture. Oops, actually, let's get rid of that. I think we drew it this way. So we drew 2 parallel lines. So 2 parallel lines, okay? We'll call this A, B, C, and I can't remember if this was E and D or something like that. But anyway, it doesn't really matter, okay? And let's say we tell you that this side up here, this is, let's think, this is 10, this is 12, okay? And that's from E to C, and this is 12 from D to C, okay? And we also know that this side is let's say that side there is let's say it's 15. Okay, that's 15 right there. Can we find x here? Can we find that distance there? Okay. Well, let's see if they're similar first of all. So what do we know here? So we've got 2 triangles. We've got triangle ABC, and is that similar to the other triangle here? So we know that I'm just going to draw DEC here. So that was 12, and that was 10 right there. Okay. Well, what we know between the 2 triangles is that this angle here, C, is shared between both triangles. Okay. But the other thing we know is because these are parallel lines, the angle here, that angle there, is going to equal this angle on the far side. So angle D would actually be the same as angle A. Now this actually is the AA rule. So we know the other angle here, because they're parallel lines, that angle up in there, that angle up there, that would have to be the same as that angle. So this diagram has 3 equal angles. So they are similar to each other. So we know that both angles have angle C. So I'm going to write my statement here. A triangle ABC is similar to blank, blank, and it would have to be a C on the end because it's the same angle. But which angle is the same as A? Or no, yeah, same angle as A. Well, that's actually angle D. So angle D would have to come first, and then angle E, because E is also the same as B. So we know this because of the AA rule. We have 2 angles, we should have 3 angles that are all the same angle. So I'm trying to find x here. So let's take a look at our diagrams here. So I'm going to say that what I'm trying to solve for is x, but that's actually side AD. So what I'm going to look at side AC, and I'm going to divide that by side DC. And that's going to equal the same as the big triangle, which is BC, divide by the smaller triangle, which is EC, or CE if you want. So let's do AC. AC, A to C is x and 12, so to add those. So that's x plus 12 all over DC, which is 12. Now BC is 15, and EC is 10. Okay, so we're almost done here. Okay, so we're going to let's cross multiply. Yeah, let's bring the 12 up here. So I'm going to times both sides by 12. Put that in brackets. Okay, so when I do that, the 12s cancel, and now I have 15 times 12 over 10, and I'm going to bring that down now. So let's go x plus 12, and let's use our calculator now. So we're going to say 15 divided by 10. So 15 divided by 10 is 1.5, and you add that, or you times that by 12, and that's going to give you 18. Okay, and now we subtract 12 from both sides, and we get 18 subtract 12, which is 6. So side X is 6 units long. Okay, so I'm going to stop the video here and give you some questions to try, and I'm going to do another video just going through some other examples to help you out with that. Let me just pause that for you guys.